Hi, Kinesiology 3010. Welcome to our first lecture on inferential statistics. Okay, we're going to talk today about research design and talk a little bit more about creating research. We've only learned about relationships with correlations, and we've learned about descriptive statistics. Now let's talk into a little bit more of the research behind how research relates to creating or deciding which statistical model we're going to use, and how the statistics give us more information. Okay, so research design start with research questions. Okay, so what do we want to learn? And statistics are closely related to the design because the selection of the statistics depends on the design of the research. So we need to have our clear research question. Based on that research question and what we want to find out, we will use a statistical approach that fits the question and fits the design of that study. So we have to mesh them together. We know that correlation does not mean causation. So if we're trying to find a cause and effect, we can't use a correlation as our statistical test. It's not going to work. It's not going to give us the information we're trying to find. So these two have to go together. Okay. We remember from before we have specific variables that can be within categories. They can be different types of variables, but these are traits or characteristics. We have two different types of variables within our research design. We have independent variables and dependent variables. You do need to know this for your quizzes and your exams, so make sure that you understand these. The independent variable is what you control, or what the research decides is the researcher decides is the cause or the input. This is what we have control over. A dependent variable is a response or the effect or what's happening, what we're measuring based on our assessment, our test, our measurement. This is what we are measuring. So independent variables we control, dependent variables we measure. Okay, so let's go a little bit further. We'll come back to these topics. Okay, what types of research designs are there? We have descriptive studies, correlational studies, and experimental research designs. Okay. So these are the three major types we'll use in this class or talk about in this class. A descriptive question gives us things like we're looking for percentages and frequencies, and we're just kind of describing the data. There's no real comparison. There's no relationship. We're just looking at what happened and giving us some descriptive information about what happened. Relationship questions, we're looking for a significant relationship between two variables. So we have one population or one group that we assess, and we're trying to see if two variables are related or associated with each other. So as one changes, does the other change? Okay, this we will use a correlation as our statistical test. Okay, so relationship questions, is blank associated with blank, is blank related to blank, will be a correlation statistical approach to a relationship question. They go together, they have to, okay, for these relationship questions, for this class. And then for difference questions, is there a difference between people with this compared to people with that? Is there a difference if we do this compared to that? Placebo control. These we will use tests like a t-test or an ANOVA, an inferential statistical approach, using our inferential statistics like our t-test, our independent and dependent t-tests, or our ANOVAs. These are some of the examples of difference-based statistical approaches. Okay, so descriptive questions will give us information about what happened. Relationships look at how two variables relate to each other. Difference questions are comparison questions, cause and effect questions, if then this. We will use a difference-based statistical approach like a t-test or an ANOVA. You cannot use a correlation for a difference question. You can't use a t-test for a relationship question. You can't use a frequency distribution for a difference question. Okay? We have to use the statistical approach that corresponds with the research question type. Okay. So with descriptive studies, we are looking at what naturally happens, what's going on. We're looking for just information about the group. Often it's frequency or percentage. So if we're looking for what is the frequency of, or what is the percentage of, you're looking at a descriptive based question. Okay, these are often surveys or observations. So like our survey questionnaire, we're looking at how often people choose resistance training as their physical activity. And then we take our survey and we look at how many people out of those, what was the frequency, how often did it occur that resistance training was the choice. Or we're looking at a video observation, field observation. We see this a lot in sports when we're looking at just general descriptives like what is the batting average of the team. So we take the team, we record their behaviors, and we look at the average that happened. Okay, that just gives us information about what occurred. It's an observation descriptive study design. With a correlation design, we're looking at the relationship between two variables within a single group. Okay, so we have a large sample and we don't divide our subjects. We use all of our subjects or our participants as one sample. Okay, and then we want to determine if there is a relationship between two or more measurements. So is height associated with weight? Is weight associated with physical activity per minutes per week? But it doesn't tell us cause and effect relationships. It only tells us linear relationships. So as one changes, does the other change? So some examples here, relationship between perceived competence, so how good do you think you are, and motivation and physical activity with college students. So do people with more perceived confidence become more physically active? Do those with less confidence be less physically active? Or is there a relationship between lower body strength and running performance? Okay, this is one that I'm interested in. When I was in graduate school, I was looking at lower body strength and performance in middle distance running. Do people who are stronger run more effectively? Okay, it doesn't mean that strength makes you run faster, that running faster makes you stronger, but are they related? If one changes, can we predict that the other might change? With experimental research designs, we're looking at cause and effect between our treatment or intervention, the independent variable, and the outcome, the dependent variable. That's where these come into play. Okay, we're looking at, as we manipulate something, what happens. Okay, so when we have an experiment, we're taking the dependent variable is what we study whenever we alter the independent variable. So what do we measure when we change something? So with this, we know that we have to have sample randomization, a control group, okay, where there's no intervention, and we have to manipulate an independent variable or a treatment of something to measure an outcome. So if you see these must all be present to create an inferential statistic or a experimental research design. So if you see an independent and dependent variable or a manipulated independent variable, measured dependent variables, we're using probably an experimental research design. So here's an example. Whether taking vitamin C pills daily makes you live longer. So we are taking our independent variable, which is do you take vitamin C pills or not, and our measurement is longevity. So do the people who take vitamin C pills live longer compared to the people who do not take vitamin C pills? Okay, so for example, to create this, we would have one group take them daily, the other would take maybe a placebo pill, and they don't know which group they're in, and we measure longevity. So the dependent variable would be their lifespan of vitamin use or no vitamin use, and we would use a t-test for our approach. We'll talk about t-tests a little bit later. Okay, this is inferential statistics. Okay, so this takes a sample and gives us the opportunity to make a generalization about a population. So maybe we take our sample and we see that those who take vitamin C pills live longer compared to those who don't. That gives us a generalization that we think, hey, taking vitamin C pills may affect longevity and may give people more longevity. Okay, these are all based on hypothesis testing. Okay, so we have a hypothesis which, based on our information, can give us a generalization on what's happening. So maybe you make some observations, you think, hey, I think vitamin C pills will make people live longer because people don't get enough vitamin C and we need it. So my hypothesis is that people who take vitamin C pills will live longer compared to those who don't. Now I will create my test that we saw earlier to see if that occurs. We'll take a sample of a population and test them. Some get it, some don't. And we see what the result is on the dependent variable. Okay, But there's some risks with this, with hypothesis testing. Okay, we could possibly have two different types of error. We can have a type 1 error or a type 2 error. Okay, if there is no truth and we conclude there is truth, then we've made a type 1 error. So saying that there is no truth and concluding that or if there is no truth about the population and we conclude that there is truth, then that's a type 1 error. So there's nothing, but we think there is, or we say there is. That's an error, a type 1 error, because that maybe it was a different sample. Maybe that sample doesn't accurately describe the population. Maybe we made errors in our study. Okay, we don't want to make a type 1 error. We don't want to say there is when there isn't. Okay, and then we have our type 2 error when we say there is existing truth, but we conclude that there's no truth. Then we commit a type 2 error. So if there is truth, or maybe there is a difference, or there is a difference between groups, but we don't find it, and we conclude there's no truth, then we commit a type 2 error. Okay, so pause this, write these down, take notes on these. You need to know these. You need to know these in situations. We'll go through some situations in a second. Okay, but if there is no truth, no existing truth in the population, in the world, and we conclude that there is, then we can commit a type 1 error. We want to avoid this as much as we possibly can, saying there is truth when there isn't. Okay, now say there is existing truth, but we conclude there is no truth. So there is truth, but we don't find it. That's a type 2 error. We'll get into how we can and can't find truth a little bit later, but this is not as detrimental, but we don't want to make this error either. Okay, so here's an example. Okay, a researcher claimed that he found a medicine that had significant effects on high blood pressure patients, but the truth is that it doesn't work. Okay, what type of error is this? Pause your video, write it down. All right, what type of error do you think this is? If you put type 1, you'd be correct. Okay, because there is no truth. Okay, but we said that there was. That's a type 1 error. Okay, let's go through another one. A company spent $3 million to study a new medicine to treat high blood pressure. The medicine actually had great effects on high blood pressure, but the researchers failed to find the truth. Okay, or they didn't find the effect in the sample that they studied, and announced that the medicine had no effect because they didn't find it. Which type of error is this? If you said type 2, you'd be correct. Okay, because there is truth, but we failed to find it. Okay, let's try another one. If researchers use hypothesis testing to examine the relationship between family income and nutritional supplement consumption and concluded that there was a strong relationship between family income and nutritional supplement consumption, but actually there was no significant relationship, the research would have made which type of error? So it's a little bit tricky. We're in a relationship, but we still can make these errors when we make a hypothesis. Okay, so what error do we think we have here? Type 1. That would be correct because we concluded that there was truth when in fact there was not. Okay, let's try this again. Okay, I'm going to give you as many examples as we can. If researchers examined the relationship between age and physical activity and concluded that there was no significant relationship between age and physical activity, but actually there was a significant relationship, but the researchers failed to find it, then the researchers made which type of error? Okay, that would be type 2, okay, because we concluded that there was no relationship or failed to find a relationship when in fact in reality there was. Okay, this is our type 2 error. Okay, so when using hypothesis testing, you have to take some risk to make these errors. Okay, you're always going to have a risk of making a type 1 and a risk of making a type 2 error. Okay, so which error would you take more risk on taking? It would be a type 2. Okay, we'd rather fail to find something than say that there is when in fact there isn't. So we want to minimize our type 1 error. This is going to get into our later conversations. We want to limit type 1 error as much as possible at all costs, and then try as best we can to limit the type 2 error. We would rather make a type 2 than a type 1 error because there could be some major consequences if we say that something is true when in fact it is not. Okay, so in summary, last bit, okay, just review these real quick. There's no existing truth, and we conclude that there is, we commit a type 1 error. So when there's no truth and we say there is, type 1 error. If there is truth and we say there's no truth, or we fail to find the truth, type 2 error. They fail to find the truth is type 2 error. Okay, this all plays into our alpha level. Our alpha level is our risk of creating a type 1 error, or risk of making a type 1 error. So write that down, make a note. Alpha level is the risk of a type 1 error. Alpha is selected by the researchers. We predetermine our alpha level. What is the risk that we're willing to take to possibly have a type 1 error? Within kinesiology research, it has been kind of set or predetermined that an alpha level of 0.05 or a 5% chance of a type 1 error is what we will be okay with as a holistic group. Okay, so 5%, or an alpha level of 0.05. Okay, if the alpha level is set too low and making our type 1 error really small, then that increases our chance of a type 2 error. So we're kind of trying to balance that scale of what's our risk, and we've set it as alpha level as 0.05 and a beta level, or a risk of making a type 2 error is going to balance out if we get an alpha level of 0.05. Okay, so that is pretty much set in stone. We can modify our chance of making a type 2 error by manipulating sample size and research design. Okay, so we can't really manipulate alpha, but we can give us some leeway when it comes to making a type 2 error. So there's trade-offs between the two, but we really want to minimize a type 1 error, or keep that alpha level at a low percentage, or for our sake, for kinesiology, 0.05. Okay. If we think about this, we're setting our significance level, or our chance of making a type 2 error at either end of that distribution curve, if we want to think back to our distribution curve. Okay, so that critical value, so the value where we're like, okay, this is where our risk is. Okay, we want to minimize that risk and put it to a low percentage comparatively. Okay, so this is a visual of, okay, this is our risk of making a type 1 error. If we can find a value that's in here, okay, we're going to say that there is truth because we've set our rejection regions. Okay, so those are our rejection regions. Everything else we will be okay with. We'll get a little bit further into there, but I want you to really think, or the things that I want you to remember is right here, type 1 and type 2 errors. So stick these in your head over and over and over. Type 1 error, there is no truth, and we conclude there is truth. Type 2 error, there is truth, and we conclude that there is no truth, or fail to find truth. Okay, all right, thank you. That's part 1, and we'll get on to part 2 in our next video.